So in this example here, we have 5 students that can be selected. Okay, they're going to be selected through this spinner, and they can win one of 6 prizes here. Okay, so there's 2 events here: selecting the person, selecting a prize. Okay, so since there are 2 events, we probably want to set up a sample space of a grid. Okay, so it does say make a table and show the sample space. Well, here are the people: Anna, Bob, Colin, Dave, and Ella, and our 6 prizes I've just listed as numbers. So we're going to select spin the spinner, and then roll the dice to get the prize. So we have these consecutive events going on. Now, it says here, how likely is it that Anna or Dave will get a Slurpee or free lunch? Okay, the or is really troublesome. Okay, so we have to be really careful with the or. So I'm going to just highlight here, this is Anna or Dave. Okay, and they're going to get a Slurpee or a free lunch. Okay, so I'm just going to highlight the Slurpee or a free lunch here. So Slurpee is number 1. Okay, and free lunch is going to be number 5. So I'm going to highlight that. Okay, so we want to try to, we have to actually interpret this first. So if I want Anna or Dave, and it doesn't matter what they get, okay, and also I want to get a Slurpee or a free lunch, it doesn't matter who gets a Slurpee or free lunch, then we're looking at the entire colored region here. So 1, 2, that looks like it's 5, 10, 15, 14, 18 out of 30. So sample space is 30. In this case here, we're going to interpret this as how likely is it that Anna or Dave, just those 2 people, get a Slurpee or free lunch, just those 2 prizes. Okay, so if we look at that, if we interpret it in that way, okay, this is Anna getting a Slurpee, this is Dave getting a Slurpee, this is Anna getting a free lunch, and this is Dave getting a free lunch. Okay, so if we want to look at it in that way, okay, we will and we're going to interpret that way, the probability works out to be 4 out of 30. Okay, so if we want to be inclusive and say that Anna or Dave, Slurpee or free lunch, it doesn't matter if Anna or Dave get some other prize, or if the Slurpee or lunch gets won by some other person. Okay, then that would be a different problem. So we're just going to interpret this as Anna free lunch, Anna Slurpee, Anna free lunch, Dave Slurpee, Dave free lunch. Okay, and if we do that, we get the sample space clearly shows 4 out of 30. Okay, so in this case here, so shade the rows that correspond to Anna Dave. So it's the fraction of 5 rows. What fraction of 5 rows did you shade? We shaded 2 out of 5. Okay, so we're going to shade the columns that correspond to Slurpee or free lunch. We shaded 2 out of 6. Now, if we want to work out the probability when we combine these two, so although it's Anna or Dave, and it's Slurpee or free lunch, we're actually combining them with an and here. And because we're combining with an and, we can actually see what happens when we multiply them together. So when we look at the total fractions of the shaded that are double shaded, okay, so we end up with 4 out of 30. Okay, so that was a problem, original problem. And we can actually combine these two. Although there's an or in here, when we combine this group with this group, okay, we can combine these 2 probabilities with ands. And so when we multiply these 2 probabilities together, notice that we can actually make it work. Now this is a really particularly hard problem because we have to make sure we understand how we're interpreting this. The or part we had to get through our sample space. The or part here we had to get through a sample space. But when we combine these independent events, so the selection of the person and the selection of the prize, these are independent events and they're consecutive events, okay, we can combine these with multiplication and we end up with the right answer. So this is kind of hard to do. Again, the most reliable thing to do here is actually just look at the sample space. Okay, there's 4 spaces that we want out of 30 total. Okay, but if we're careful, we can do this such that we can use these multiplying probabilities to help us with a problem like this. Okay, but again, if we're ever stuck, we always go back to what's simpler, use the sample space. So for this one here, this one's actually a fairly tough problem. Okay, and it's actually kind of involved, so we have to be kind of careful with this one. So there's 2 boxes. Okay, we have 3 cookies. Box A has 2 chocolate chips, so these are chocolate chip, and 1 oatmeal, that one there. And box B has 2 oatmeal and 1 chocolate chip. Okay, so basically what's going to happen is we randomly select a box, and then a chocolate chip cookie is taken out of the box. So it could have been box A, could have been box B. We don't know. So what's the probability that another cookie is selected from the same box as chocolate chip? Well, that's going to be dependent on which box we're in. Okay, so if we're in box B, there's 0 probability. If we're in box, and we could possibly be in box B. There's no certainty about it, but there's a possibility or probability we're in box B. If we're in box A, the chance of getting another chocolate chip is 50% because there's only 2 cookies left and one of them is chocolate chip. So, and there's a possibility again that we're in box A. So how do we go about doing this probability then? Okay, so think about that and see how you would set it up.